This video covers the rest of our first learning target for our unit on exponential functions. We're going to talk about rational exponents as well as exponential equations that we can solve. This learning target says I can apply the properties of exponents and solve exponential equations. So let's first talk about these rational exponents. By rational, I mean fraction exponents. There's two important parts of every fractional exponent. There's the numerator and there's the denominator. The numerator is the power on the x. So when we turn a fractional exponent into a root, that one that's on the top of the fraction is actually the power on our x. The 2, which is the denominator of our fraction, is our root, or how big the root is. Since it's a 2, this is a square root. I'm not going to write a 2 here because when there's no number written, it means square root. So let's do that one more time. For z to the power of 2/3, 2 is our power. That is why it's now just on the z without the divided by 3. The denominator of our exponent is 3, which is now our root. So now, instead of saying z to the power of 2/3, it says the third root of z squared. Just like x to the power of 1/2 is equal to the square root of x. This example here has us doing 64 to the power of 3/2, or 3/2. Let's remember our pattern. Our 3 is going to be the power on the 64. The 2 is going to be our root. So I'm going to rewrite this problem as square root for the denominator of 2 and 64 to the power of 3 because the numerator in the exponent is 3. So now I'm going to go ahead and choose to either square root or cube. I'm going to cube it first since that is inside the radical sign. So 64 to the power of 3 is a pretty large number. Now that I have what 64 to the power of 3 is, I'm going to go ahead and square root that number. And I end up with an answer of just 512. The second part of today's notes is about solving exponential equations. What we want to do is we want to work with the idea that the x could be the exponent. The exponent might be our variable. This is a new idea. We've never had a variable in the location of the exponent, but it's not going to be too hard to deal with. Let's consider x as a power on 3 and what that x should be in order for it to turn into a 9. Well, since 3 squared will equal 9, then my x is equal to 2. Let's think about this problem. 2 to the what power makes 1/8. I do know that if I were to take 2 to the 3rd power, it would make 8, but that wouldn't give us our answer. We want 1/8. So in order to get 1/8, I'm going to need to do it to the -3. Then it will be 1/8 instead of just 8. So my x in this problem is equal to -3. In this problem, we are already given exponents on both sides. Notice how on both sides we have the same base, which is 4. Since the bases are the same, I now can just consider this as a problem of solving exponents. So a plus 3 has to equal the other 3. Let's subtract 3 on both sides, and that means my a is equal to 0. So a is equal to 0 is my answer. In this problem, I see on both sides the equal sign is not the same base. We could transform the 125 into something with a base 5. So let's try to get the same base. I know that 5 to the 3rd power is 125. Let's substitute the 5 to the third power in the spot for 125. Rewrite the left side of the problem. Now that I have transformed my 125 into something with a base of 5, now I can just work on solving for the exponents, 2x and 3. Solve this little tiny problem by dividing by 2, and my x is equal to 3/2. In this problem, I'm seeing a combination of things happening. First off, there are two pieces here with the same base, and on the other side of the equal sign is a 36. What could I do to the 36 that would transform it into something with a base of 6? Well, if I put 6 squared, that would be the same thing as 36, but now I have a base of 6, which matches what is happening on the other side of the problem. Now that I have all the same bases, I can set up this problem. Do know that since we have 6 and 6 same bases and they both have exponents, this is product property. And product property says that the exponents add. So I'm going to set this up as the first exponent, there it is, plus the second exponent should be equal to the exponent of 2 on the other side, since all of my bases are all 6. Let's solve this equation made up of exponents. I have like terms. Negative 3b plus 2b is just negative 1b minus 2 equals 2. Let's add 2 to both sides. Negative b is equal to 4. That means b is equal to negative 4. There's my answer for b. The b in this problem is negative 4. That's all the variety there is about these problems, how to transform fraction exponents, or what are called rational exponents, into problems with root signs, such as square root, cube root, and fourth root. And also we learned about how to transform problems, which are equations, into problems that all have the same base, and then solve for just their exponents. If you have any questions, make sure you write them down, or you can, of course, send me a message and go ahead and click forward, answer the questions, and hit the submit button.